From the very important concept of love for variety for trade, now we go to very important concept of trade elasticity for trade. So like now, Simonovska will present trade models, trade elasticity, and the gains from trade.
Not this. I should hold this. Okay.
No, this one, right? Yeah.
I think so. Yeah. Great. Well, what? Oh, okay. Thank you so much to the organizers for including us in the program and for pushing us to finish this paper or revisit this paper that's been around for a really long time. So for a lot of you, it's going to be familiar. I'm going to try to show you some new things that we figured out over the past week. So, okay. So what are we trying to answer in this paper? So basically the question is, how do different margins of trade affect the estimates of the welfare gains from trade? And on the theory side, our Kalakis, Costino, and Rodriguez-Clare gave us a very nice result, which basically says that the welfare cost of autarky is summarized by two things. The first thing is data, lambda n, that's just the share of goods that we're buying from domestic sources. And the other object is theta, which is the elasticity of trade, which is a parameter that needs to be estimated. As they showed, this formula holds for a wide class of models, specifically sort of models that include extensive margins of trade or variable markups, such as the Eaton and Cordham or BJK model, Bernard, Eaton, Jensen, and Cordham, but also as well as the Melitz-Alachanet model. But also it holds true for models that exclude these margins, such as the Armington and the Krugman model. So then their conclusion was that given a common estimate of the trade elasticity theta, the welfare gains must be the same, which comes straight out of the formula. Okay. So our answer to this will be somewhat different. We will argue that the trade models, different trade models that have different micro-level margins will actually require lower trade elasticities or thetas in order to generate the same amount of price dispersion and trade. So in a nutshell, think models are different. They have different predictions about the price dispersion. So if you want to hit the same moment in the data, it's got to be that the estimate of the trade elasticity or that parameter that generates these moments is different across the models. And in particular, there's going to be an ordering such that models that feature more margins of trade will end up needing a lower trade elasticity to match that same moment. So then that'll rank the models according to trade elasticities as well as according to the estimated welfare gains from trade. We'll show you that quantitatively these differences can be quite large, varying from about a quarter to a third. And then we'll compare, and this is sort of the newer part, we're going to compare our estimates to an approach that also uses cross-sectional data, but on trade and tariffs rather than prices, and we'll show you how those differ. And specifically, once we put the two approaches together, we'll see that our approach is going to kind of systematically recover the same trade elasticity, whereas the alternative approach will give you quite varying numbers depending on what year you look at. So here's what I'm going to do today. I'm going to spend 1 minute on the models because I'm hoping that everybody sort of knows these models. I just want to fix ideas and define terms mainly. I'm going to show you the theory of estimation in pictures. I'm not going to spend too much time on estimators. I'll just kind of give you an idea on how we identify things. And then I want to focus on the numbers mainly. And then on the difference with what I call the macro estimation or the estimation that comes out of tariffs. I'm mainly going to focus on the three models that don't include monopolistic competition. So that is to say the Armington, EK, and BJK model. We're going to get to Melitz and Krugman at the very end, time permitting, because the estimation is slightly different and slightly less intuitive. Okay. All right, so let me get started with the models. So the first one is Anderson or the Armington model. In particular, we're looking at the symmetric version of Armington to fix ideas. So that is to say there is a unit measure of tradable goods. There's a subset of differentiated goods by the source country, I. So think if there's n countries, each country produces 1 over n of the goods, of that unit unit measure of goods. But of course, everything is consumed everywhere. This is Armington, right? So everybody has access to all the goods. Utility is CES. And then there's perfect competition. Prices simply reflect the marginal cost of production and delivery of the goods. There is no extensive margin of trade here, only the intensive margin of trade. Then let's add Eaton and Cordham on top of that. So the way that we think about Eaton and Cordham is basically Armington, but with an extensive margin of trade. So what do I mean by that? So again, there is a unit measure of tradable goods. They're not differentiated by source. Perfect competition here, CS preferences. And what's interesting about EK is that producers will differ according to their productivity with which they produce a good. This productivity is drawn from a Frechet distribution where the shape parameter is theta, and that's going to be the trade elasticity in these models. This is again a perfect competition model where price reflects marginal cost of production and delivery, but there's endogenous tradability or extensive margin of trade. That is to say, while everybody's consuming the unit measure of goods, they're not necessarily purchasing those goods from the same source, right? Some of those goods are traded in equilibrium, some are non-traded in equilibrium. And then what is Bernard, Eaton, and Jensen and Cordham? So basically, that would be the Eaton and Cordham model, but with Bertrand competition rather than perfect competition. So here, the price will reflect the price of the next best competitor. Once again, the productivity will be drawn from a Frechet distribution with that same shape parameter theta. However, now the prices of the individual goods will differ since it's not perfect competition, right? The price of the next best competitor will matter here. So relative to Eaton and Cordham, this model features not only endogenous tradability or an extensive margin of trade, but also variable markups. Okay? So let me just give you the notation for these models and how they sort of relate to each other. So despite the differences in all the micro predictions, these models kind of collapse on aggregate to one equation, and that equation is written on the slide here. So the following are the trade flows, trade shares of goods from country I to country N. So trade share is, the trade flows from I to N divided through by the total expenditure in country N. And I'm dividing that through by the trade, by the domestic share of country I. So I'm normalizing by the domestic share of country I. So that is equal to the ratio of these objects phi, as well as the bilateral trade barrier between countries I and N raised to the power of minus theta. So what is this object phi N? So this is something that comes out of all the models, and it basically reflects the location parameter, TK, sorry, does this work? So TK is the location parameter of the Frechet distribution, or think of it as like the mean productivity in the Armington model. Tau is the trade barrier, and W is just the wage. Okay? So all of the models generate the same equation. And in these models, let's think about what theta represents. So in the Armington model, it is the love for variety parameter. In the EK and BJK models, it is the micro-level dispersion of productivity, right, that Frechet parameter. In all of these models, looking at this equation, it's very clear that theta is measuring the response of trade to changes in trade costs, right, once you log this. And from the first slide, we know that theta is critical for measuring the welfare gains from trade. All right, so now let's start thinking about how to get at theta. So to get a sense of our kind of main result, I'm going to make a simplifying assumption. So I'm going to look at a two-symmetric country version of these models, because then I don't have to deal with these phi's, so I can kind of get the idea through pretty easily. Okay? So if we have two symmetric countries, home and foreign, then the trade flows collapse to a very simple equation where I've just replaced the I's and the N's with H and F for home and foreign. The phi's go away due to symmetry, and then you just see that everything is basically collapses to the trade barrier tau raised to the power of minus theta. Okay, so now suppose that we constrain the model such that tau and theta match the same trade flows across models. So that is to say, think of tau and theta having been estimated so that the left-hand side is identical across models. So then the only reason why models would differ from each other is the combination of theta and tau. Does that make sense? But the product is fixed. Or whatever, the thing raised to the power is fixed. It's a product once you take log. Okay, so now let's think about how to get at theta. So I'm going to define a couple of terms for you, which are sort of don't worry too much about the math of it, but just the idea of it. So let me define for any good the logged price gap between the home and the foreign country. So that's going to be this object, log p tilde h. That is simply the log price of a good in country H minus, so home, minus the log price of a good in country F, which is foreign, okay? And let's think about what does this object look like. So there's a distribution of this object. The distribution, we call it GM, M for a different model. And let's try to visualize this distribution. Well, if we're looking between the price of a good between the home and the foreign, and we're looking at a good that we're potentially importing from abroad, we know a few things. First of all, that relative price in logs cannot be below 0, right? It's bounded at 0. On the top, it's bounded by the trade barrier, right? Because this is a no arbitrage condition. And then there's some mass in between. And that mass in between 0 and the trade barrier effectively depends on the model, okay? So I'm going to show you some pictures on what that mass looks like in a minute. But before I get there, I just want to define one more object, which is the following. So I want to think about potentially drawing observations from that distribution, GM, that I just described. And suppose that I draw a number of observations from that distribution, call them order statistics, and then suppose that I rank these order statistics from the smallest to the largest, okay? So then I'm going to define the maximal price gap to just be some kind of a max of those order statistics for a given sample of goods. So if I've drawn 10 goods, I'm going to look at the max among those 10. If I draw 60, it's going to be the max across those 60. Okay? And I'm finally going to just define the expectation of that object. Okay, so whatever that expectation is, of course, you recognize that that expectation is going to depend on the number of objects that I draw because it's an order statistic, it's a max. Okay, so now let's visualize these things. So what I'm showing you here is the distribution of the price differences for each and every model, okay, against the actual draw, right? So this is just the density. So what do we see here? The Armington model just gives me a straight line, that's the blue line here, that exactly corresponds to the trade barrier. So why is that? Remember, the Armington model is a model where there's no extensive margin of trade. So the difference in prices for any imported good, it is exactly identifying that trade barrier. There's nothing else there, okay? However, the EK and the BJK models contain some mass prior to that tau, okay? Now, look at the EK model, which is the red line. So there's some mass going from 0 until that trade barrier, and then there's also some mass right at the trade barrier. So what is that reflecting? It's reflecting the fact that some goods are tradable and some are not. So the goods that are not tradable, I shouldn't say tradable, I should say traded, because they are all tradable, but actually not traded in equilibrium. The goods that are not traded in equilibrium lie to the left of this blue line. Similarly, for the BJK model, the goods that are not traded in equilibrium lie to the left, but the red and the black lines, which are DK and BJK, are not the same. So why are they not the same? Because BJK includes variable markups, and we're looking at the relative price of goods. Okay? So that's taking us yet away from the trade barrier. Think of the markup as introducing like an extra wedge between the trade barrier and you, right? It's an extra distortion. So it's taking you away from that tau that you're trying to measure. So why do we find this picture useful? Because now I'm going to go to the next picture that says, suppose that you're setting the expected maximum of the relative price differences to be the same across models. So now I'm trying to hit the same number, some number that I've made up. It's going to be a number in the data, but some number, expected max, with the 3 different models. Well, then it's got to be that to hit that max, the distributions are going to have to, the distributions of prices are going to have to adjust. How so? Well, the blue line here, that's the Armington model, that's easy. There, I already showed you that the relative price is always the trade barrier. Well, then therefore, the relative price is going to be the expected max as well. So that's super easy, right? But how about the EK and the BJK model? Well, given that the shapes of the distributions that I showed you on the previous slide, it's got to be that the EK model will have to go way past the expected trade barrier in order to hit it in expectation. Why? Because I already told you that you'll be picking up a lot of price differences that are below that max, below that trade barrier. So if you want to hit the max, then you have to overshoot with the distribution. Similarly, with the BJK model, you have to go even further because there's this extra kind of distortion, which is the markup. Now, but how does this translate into the actual thetas or the actual trade elasticities that are behind them? Well, remember the theta object in EK and BJK is regulating the dispersion of relative prices or dispersions in productivities. So if you want to get a higher dispersion in prices or a higher dispersion in productivities, that theta has to be lower. Okay? So what I've done here is to effectively rank the thetas of the models from the lowest to the highest. And that's, yeah.
So how do you think, is it literally low fund price deviation, or you think you fix the level of aggregation to like...
Oh, sorry.
Is it literally low fund price deviation for a variety, or it's like you fix level of aggregation to HS6 or HS10 and look at price differences? I think
So,
that's really what it is.
good question. So the prices that we're going to be looking at are prices that will come out of the ICP, International Comparison Program. It's neither nor, let's put it that way. It has its own classification. So these are the prices that are used in order to generate the expenditure weights in GDP. Okay, we're going to focus on only the tradable goods part of it. There's going to be 62, Mike, prices. And the typical observation there is, so a lot of the items it's basically consumer items, but think rice will be an observation. Okay, now what is rice? So there's actually micro price data for some of the later years, not the ones that I'm going to use in my first estimation, but later on I'll show you some other numbers. You can get observations on actually not just the price of rice, but the price of basmati rice versus black rice versus white rice versus, I don't know, this type of rice, where you can get at the varieties. Those are not going to be appearing in every country. But the price of rice you will observe in every country, which means that the price of rice, the way that the ICP, the International Comparison Program, computes it, is actually a weighted average of the prices of the different varieties. And specifically, they use actually a geometric mean of prices in order to arrive at it.
And just to clarify, in the models, EK and BJK, it's not literally the variety.
In EK and BJK, is literally the good. I don't want to call it it's fine. Call it a variety. So within a unit measure of 0 to 1. So we have put rice and corn and whatever potato
but supplier of the
across.
can be different in different markets, right?
Yes. Yeah. Yeah.
All of this is under the assumption that it's two countries, which basically...
No. The theory is in the estimation where everything is.
Yeah, that's my question. So how do you go from that to a more complex world that not only means that the bilaterals are not going to be the same, which is what you get when you impose the two countries. When you impose the two countries, they cancel.
Yeah.
So that they don't cancel when there's a lot of countries, but then there's also the intertemporal.
So there's no intertemporal here, right? So everything is in the cross section, but having multiple countries, an asymmetry doesn't matter. That's why I kind of showed you the very first thing here, which were the phi's, they're going to show up in the estimation. It's just that I can't characterize that by pen and paper, so I'm not doing it. But that's absolutely going to be part of the estimation. So that's not a problem. But across time, we're not going to be identifying everything from time varying prices, but I will be doing estimation in multiple time periods and comparing it.
Do you have capital goods?
No, this is a static model. There's no capital goods. I probably...
ICP has housing.
Oh, no. ICP has housing, but we don't use that.
Okay.
We are using tradable goods.
Fair enough.
Yeah, sorry. Yeah, and absolutely. Yeah. Okay, so I think I did... Now I forget where I was. I think we were here. Okay, we had ordered the thetas, and that's effectively the theorem, which I'm just going to summarize for you. I'm not going to go into much math. But suppose that you have the following estimator for theta, which is to minimize, basically, the difference between this log price difference, the max of the log price difference, which is what I defined a few slides earlier, and that expectation of that. So that is to say, you have a model, right? You have a bunch of goods, 60. You take the max of the relative price for each country pair, and you're comparing that to the expectation of that object, okay? And suppose that the estimator is to minimize the difference between the distance between those two, okay? Then you can show that given the distributions that I showed you in the previous slide, the thetas would be ranked. The estimated thetas would be ranked according to this estimator, which translates directly into a ranking of the welfare gains from trade using the Arcolakis-Costino-Rodriguez-Claure formula. Okay, so this is just summarizing the kind of pictures that I described. Okay, so yeah.
This estimator, this reflects the max or?
The max. That's log P tilde HLL. I had defined to be the max.
Got it.
Maximal price difference. Yeah.
Yeah, I mean, I guess the question, what will happen if you deviate a little bit from this estimator? And
yeah. So unfortunately, we don't have a proof for that because we cannot describe we cannot show the properties of the distribution with multiple moments. But of course, in the estimation, we will be doing multiple moments, and I will show you that the results will how the results will change. But that's something that we can only do when we estimate things. So we'll get there, absolutely, yeah. But it's the same sort of idea will be coming through. It's just not as precise. Okay, so let's try to quantify these differences. Okay, so specifically, this is how we're going to implement the estimation approach. So given a set of micro-level prices that we have sampled, we will be computing the following statistic. Let me define the object DNI to be as follows. So the first part is simply the maximum log price difference between countries N and I is the sort of foreign and is the home, across the different goods L. And then after that, I'm going to add the logged price, I'm going to add the log price index, think of it, for country I, and subtract the log price index for country N. So Laura, this is sort of getting at your question, is that basically, if you see this definition of DNI here with these P bars, which are averages, okay, those are effectively getting at the phi's that were over here. So that's like the CS price index, which is approximated here by the mean of logged prices. Okay, and you can play around with that, and we're doing that with the actual approximation. But in the models, that's exactly what the approximation should be. Yeah.
Since you are taking log, does it matter if there is noise in the data? So can you just add some noise term and then estimate the noise and incorporate?
Yes. Thank you. A good question. Yes, it does matter. Yes, the noise does matter. We do estimate it. And it doesn't change the rankings across models. It does change the actual numbers. You can look at the paper to see by how much. I don't have time for that. But yeah, yes, absolutely. Again, what we like about this approach is precisely what you just brought up, is that you think that there's noise in the data. Let's throw it in a model. You can do it. Like, you can incorporate all of these like frictions however you want. That's the beauty of the methodology. Okay, so right. So this is the equivalent of what I showed you earlier in theory, but for multiple countries that are asymmetric, okay, as I explained to Laura. So we're going to be basically approximating the price index for each country by the average of the logged prices for each country. So now, if you have defined this statistic, DNI, the methodology works as follows. We will be recovering all the parameters for the model up to an unknown scalar theta from trade data only. What do I mean by that? So I mean, if you kind of go back to what I showed you at the beginning, this equation here, right, where I can basically run like a gravity equation of trade, and I can get all the parameters that I need in order to simulate the model. That's coming from an equation that kind of looks like this one, where the only thing that I can't get from gravity is the combination of theta and tau, theta versus tau. But theta times tau, I can get straight out of gravity. And that's going to be the same across all the models. So I'm really fixing the parameters that way, okay? And then we'll be simulating the models in order to get the statistics, DNI, and then comparing those to something in the data, okay? So that's the idea of the methodology. So now you may ask, well, Ina and Mike, why did you guys pick these moments? Like, why these price moments, okay? Well, so I'm just going to throw a number for you here. So here are those moments DNI that I just defined, which is the max as well as the 85th percentile of that. And this is from the data, directly from the data. So 2004 data for 30 largest countries in the world in terms of GDP and trade. They account for the majority of trade. And what we've done is to project those statistics, DNI, onto things that we like to think are reasonable for trade. What are those things? Distance and border, right? Typical thing that you do in a gravity equation of trade. Well, the estimates that we get, the coefficient estimates that we get on distance and border are actually like quite comparable to what you would get if you were to run a gravity equation of trade. So these are very well estimated parameters. They are comparable in magnitude. So that is to say that this statistic, which is basically a log price difference, is actually like correlating with things that we think trade barriers should be reflecting, such as distance and border, pretty well. So it's not an absurd moment to look at, is sort of what I'm trying to get at, okay? So now let's go and try to implement this thing, 12 minutes, okay. So effectively what we're assuming is the following. We're thinking that each model is kind of like its own data generating process, right? And then we will be applying our methodology to each one of these data generating process, but fixed to the same data and trying to see how this data generating process basically matches the data. That's what we're trying to do. So we're going to have three actually different things. So the first one is the exact moment that I just described to you. So that corresponds to what we call exactly identified estimation. That is to say one moment, one parameter, right? There's no matrices flowing around. So the moment condition is just to minimize the difference between that one moment in the data and one moment in the model, okay? That gives you a very well-defined estimator as well as a standard errors. Now, what Kostas said was, why just that moment? And he's absolutely right. So let's start and think about other moments that come out of the price distribution. So we're going to actually look at three, but happy to hear for any other suggestions. So we're going to look at the max price difference, as on the first slide. We're going to look at the price difference in the 85th percentile of the sample. So trying to take some moments from that price distribution. And we're going to look at the covariance of the max price difference in distance. Since I showed you that it was behaving pretty well, right? Its distance we like to think is like the important thing for trade barrier. So let's try to hit that moment, okay? In this case, the zero function is now a vector rather than just two numbers, but the definition is the same. We're just minimizing the difference between this set of moments, but because now we have one parameter, theta, and multiple moments, it means that you have to have some kind of a weighing matrix that weighs these moments, and that's W, and we're going to be we're going to have two specifications for that W. One is the identity matrix, and one is the optimal weighing matrix, which converges with every iteration of the parameter estimate. Okay. In this case, with the over-identified estimation, we actually will be able to do some statistical inference. So you can define a J statistic, which is a test for over-identifying restrictions, and we'll be able to say our model sort of matching the data or not. So we're going to show you some of them. All right, so now let's talk about the data. So as I said, trade shares that are computed from bilateral trade flows and production. We're going to focus on manufacturing only for the 30 largest countries in 2004. And it's going to give us 62 tradable products in 2003 to 2005 sampled from the ICP. Okay? So let's look at the results. So here's the first sort of table that comes out of it. I'm going to show you different sets of results. So let's focus on the first column here that says exactly identified. So here's where we're only trying to hit that one moment, that DNI, okay, which is the difference between the max in the data and the max in the model. I should say one thing, which is that for the BJK model, which is a model that features variable markups, you also need to put a number for the elasticity of substitution in order to be able to compute the relative prices, because this is a variable markup model. So we're going to have several specifications for that. I'm going to show you first one where we're fixing that elasticity of substitution to be 2.5, which is the mean in Broda and Weinstein across different categories. And then we're going to look into specifications where we actually estimate rho jointly with theta by matching these three moments. Okay? So the first column here really shows you the theoretical result that I gave you, which is that there's a clear ranking between or among Armington, EK, and BJK, where the Armington model gives you the highest estimate of theta, and BJK gives you the lowest. So this is really the kind of the theoretical result from earlier. And now let's go to the over-identified case. In the over-identified case, when you're looking at the identity matrix as the weighing matrix for the three moments that I described, that ranking is preserved. But once we apply the optimal weighing matrix, the Armington estimate drops. So you may think, oh, is this a problem? Does this mean that the methodology is not working? Well, you have to be a little careful and look at the very last column. In the last column, we're showing the JStat, which basically tells you how the model fits the data. And this JStat is clearly telling you that the Armington model is rejected. Okay? So to get you a sense of why that's happening, I'm going to show you the actual moments in the data and the moments in the model so that you see how these models are fitting the data. Look at the Armington model, which is the one that performs the most poorly with respect to the JStat. So the Armington model is completely missing the data along all dimensions. It overshoots the mean by quite a bit. It undershoots the 85th percentile, because remember, this is a model that's predicting like that distribution that's really lined up across the blue line that I showed you earlier. But it completely messes up the covariance with respect to distance as well. So, I mean, this model is just too simple in order to be able to match price data. So it's not a surprise that we reject it. Okay? Now, what we were more surprised about is that we also reject the BJK model. But then, when we started to look at the moments for the BJK model, you know, it's our intuition here is that because the moment that kind of like, I guess, is not doing as well is the covariance one, that we're thinking that it's got to be something about the variable markups that are introducing some type of noise to the estimate of the trade barrier that's making the data reject this model. Okay? 6 minutes. Okay. So now let's get to some of the new stuff. So this is what we've done. All right. So how does this compare to other estimates? Okay. So we're going to be comparing everything to the Calienda and Parra approach, because this is an approach that's also identifying trade elasticities from the cross-section. So it's just sort of the most natural comparison since we're identifying elasticities from the cross-section. So a preview of how Calienda and Parra do things. So they're basically looking at log of triple difference trade flows for each triple country, NIH, and the log of triple difference tariffs for those same countries. And then what they basically do is an OLS regression, right, of triple difference trade flows on the triple different tariffs, okay? Crucially, the elasticity that comes out of this estimation is the same across models because you're not relying on data or on any moments on prices for these models. You're simply using the gravity equation of trade, which, as I said earlier, all the three models predict, right? Okay, so just if I were to put this into GMM terms, what it basically means is that you're, as I said, minimizing the error between, like, in OLS, you're basically just minimizing the error in this simple OLS regression of trade flows on tariffs. And this is the GMM specification for that corresponds to it, okay? So now what we're going to do is to stack their moments together with our moments and try to fit the data, okay? And I'm going to show you results here for the exactly identified case. So that is to say where we only have one moment in our data and one moment in our estimation strategy and one moment in theirs, okay? So here's the result that comes out of that. So Calienda and Parra with this particular data set, 2004, that I showed you, would give you the same estimate across all the models of 4.6. Our method, which we call micro, I don't know, we have to change this language, but there was no time to do it. Our methodology is the second one, so it gives you the ranked estimates of 5, 4, and 2.7. When you combine the two, you recover ours. Their moments are not reflected anywhere, okay? So what's going on? Like, why is estimation not picking up their moments at all? And I think this picture is sort of a nice way to summarize it. So this is the log triple differences in trade flows plotted against the log triple difference tariffs, as well as the lines of best fit of all of the different estimations, including the data. Look at it. It's a cloud, right? There's just so much noise that it's not at all surprised that once you put in something that's much, that has more identification, like ours, the data, the methodology would pick up our moments and not theirs. So that is to say, this moment is just super noisy, this tariff moment, okay, that they're using. Now, I'm going to show you the implications of that. So what we've done is to, first of all, use our methodology on 3 different data sets. So we did it for year 2004, which is what I've been showing you until now. We did it for year 2011 and 2017. Why gaps in between the years? Because ICP price data only comes in batches every 5, 6, or 7 years or so. We don't have it every year. Otherwise, I would have loved to give it to you year by year. Yeah?
I find it interesting that you get very similar results because they change a lot the methodology.
So I wouldn't say that they've changed a lot the methodology. I'm part of the ICP group, so I look at this all the time. They have been, when they compute the aggregate expenditure shares, they are imputing a lot of data. They've played around with hedonic regressions, but I wouldn't say that the methodology of collecting prices has changed.
This ring.
The ring, yeah.
They got rid of the ring because the ring was creating.
It was. That's true. But I actually think the ring was more like in the 1996. They've been cleaning it. Yeah, they've been cleaning it a lot. But I don't know. The micro prices are just not that different. Yeah. 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 No, I understand. But yeah, I think that what I've noticed is that the ring really matters when you have missing observations. But for these 30 countries that we're using, I don't think you have that many gaps. The ring is going to kick in when you're looking at like remote countries. So, yeah. Oh, right, which probably is not in our data, sorry. Okay, yes, last minute. So I showed you that our estimates are super stable across time. What does Calienda and Parra look like? So the following is the trade elasticity estimated for manufacturing trade year by year using a mean tariff, okay? the average that actually comes out is negative, and the numbers are all over the place year by year. If you look at total trade, so not just manufacturing, but also at agriculturing, mining, etc., then you get a number on average that's around 4, and that's a little bit more stable. What if you were to look at a manufacturing trade again, but you look at a trade-weighted average tariff rather than a mean? Numbers are all over the place year by year. The numbers are all over the place. Also, if you look at the total trade year by year with weighted average tariff. So again, reflecting that cloud that I showed you earlier. Okay. All right. In the last 10 seconds, what I'm going to say is that we do this for Mellitz and Krugman as well. We need a few more assumptions there in order to be able to take the models to the data. We're playing around with those assumptions right now and changing the methodology, but what we get as a first set of estimates is, again, a ranking between Mellitz and Krugman following the same intuition as you would for the previous one. That is to say, the model that has fewer margins gives the higher trade elasticity estimate, and the model with more margins gives you the lowest. Okay? That's it.
So what's the number? No, I'm just kidding.
There's no number. So, okay.
Let's discuss it after the. Yeah.
Oh, okay.
Maybe that will be your summary.
I will answer that later. What is epsilon? Which is a pressing question.
Good. Thank you, Ina. This discussion is Hiau Looi from the World Bank. Okay. You have your slides there, or?
Just I have some update.
Update, okay.
This morning I sent, I don't know whether it's there. Can you check? Which one? Can you go to the very last? Or don't share so that. Okay, this is fine. This is fine. Go to the first one.
All right.
Okay.
You have a microphone? Yeah.
Thank you so much. Thank you for having me discuss this wonderful paper. I learned a lot. In a way, I feel so sorry that I have to stand here after hearing what Kiminori was presenting, because in a way, my discussing slides speak a little bit to his paper and a little bit answering to Ahmad's comment about application. So, but I'm an empirical person. I work with a lot of numbers. This project, I learned a lot from it, but we'll see. It is actually, today is also, when I was driving here, today is also the National Teachers' Day. So I want to take this opportunity to pay tribute to my own teacher. So y'all see. This one. So standard disclaimer, what I say just is my own fault and not anybody else. So, Kiminori, I'm referring to this AER classic paper that is in the year that many of you are not even born yet, 1989. Question is, this is actually the title of the AER paper. It's called, well, the real elasticity of substitution, please stand up. So I'm sure you appreciate this. I didn't know that you are presenting a paper that is so close to my discussion slides. Otherwise, I'll take this away because I feel embarrassed. I'm sure I'll make a lot of mistakes, and I'll hear your comments on my comments later. So anyway, that is the title of the paper. It's a very short paper. It discusses the various ways to define elasticity of substitutions. And this is even before the era, 1989. Before the era that we are using all this elasticity of substitution to measure all kind of things, including gains from trade. So, just to give some background to cast where Ina and Michael's wonderful work is in this context. So, what started the storm was what I call this theoretical-based trade elasticity literature. We have Costa's paper here saying that one trade elasticity is sufficient to characterize everything. You have import share in GDP, you have one sufficient statistics called the trade elasticity. Boom, all the models, all the quantitative trade model with standard assumptions fit into this, And that is all that we need to know. And Ina did a wonderful job. She is such a great presenter, made me feel so worried. She explained this very well as to why this is the situation for all these models. And then but after that, you have Caliandro and Pauro's paper saying that perhaps we add a little wrinkles to it. How about input-output linkages, sectoral linkages? And then they estimate sectoral elasticity. So moving from aggregate trade elasticity, you move down to sectoral elasticities. And then they show that with that, you actually, the estimated gains from trade are much larger. And then you have Osa's paper in JIE 2015 saying that there is also cross-industries variation, that some industries are just much more important than other industries. Iron and steel is much more important than other industries. So if you take those linkages as well as into account, the gains from trades calculation is even more complicated. And then we have this standard magic number of 4 coming from their previous work. Ina and Michael tell us that with the EK-based estimate, the rule is 4, and all of us, me included, cite the number 4 in so many of our own calculations, because 4 is a good number. Not too big, not too small. If it is too big, all the calculations throw off, and then people feel suspicious. If it is too small, you feel kind of stupid that I spent all this time and get such a tiny result. That's no good. 4 is the magic number. And then behind all this theory-based, very rigorous work of trying to get 1 elasticity, 5 elasticity, 30 elasticity, there's a boom of empirical-based estimates, okay? Started with Coley's 1991. He used what they call the GDP function approach to estimate trade elasticity. His is only 1, aggregate import elasticity and aggregate export elasticity. Harrigan, RER 1997, used his approach based on US and other countries, estimate at industry level. This approach detached from theoretical model. They just say that imagine GDP of a country consists of domestic production, import, and export. Use actual data, estimate the elasticity. Then, boom, come QJE, Broder and Weinstein. Once upon a time, we cite this paper a lot. They estimated 30,000 elasticities. They use Finstra's approach. Later, I'll talk about, I'm a Finstra student. And then they say that, boom, we can actually estimate reliably 30,000 elasticities. And I remember sharing elevator with David. David is such a, misspell his name. David is such a gentleman. He said, oh, Key, you know what? I estimated 30,000 elasticity. And then I was doing calculation. I said, David, you know what? I estimated 300,000 elasticity using a different approach. So my original work was based on Coley's and Harrigan's work. We estimate translog GDP function, and then I bring it down to HS 6-digit level. I estimated import demand elasticity. Kibinori is going to tell me that import demand elasticity may not be the same as elasticity of substitution, but under CES they are the same. But anyway, we use brute force. We estimated 370,000 import demand elasticity. And you're going to ask, why? Why are you doing this when all of us are focusing on 1 elasticity, 5 elasticity, 30 elasticity? The reason is because there is a need for empirical research to figure out the context of when countries are trading with each other at the bilateral level, at product level. I got phone calls from EU telling me, I have a WTO dispute with the US government. Can you tell me what is the elasticity I should use to figure out injury? And then I got an email from the US government telling me that, can you tell me I have a dispute with EU? What is the elasticity I should use? Those elasticity, if I refer to the theory, I'm not sure the US or EU government will be too convinced with those numbers. But anyhow, moving forward, more recent work. So Broder, Greenfield, and Weinstein published a paper, Groundnuts to Globalization. They expand their 2008 methodology to other countries. There's 73 countries now, from Gambia to Zimbabwe, all are included. And my humble recent work focused pushing the envelope to have bilateral elasticity estimates. Bilateral in the sense that now I really look at EU-US trade, EU-China trade, US-Mexico trade, EU-UK trade at HS 6-digit level, and then I estimate the bilateral elasticity with such detail. So I don't even want to count how many elasticity is in there. You can do the math. It's just mind-boggling. But I'm not the only one pushing this, and I shouldn't, because they are newcomer. They are focusing on pushing the envelope to other dimension. These are just 2 job candidates that visited World Bank in the past few months, and their papers are on estimating trade elasticities as well. They're focusing on using protectionist retaliatory tariff as IV to estimate trade elasticity, and that they claim that leads to large welfare loss. And then there's also papers that focusing on estimating short-run versus long-run trade elasticity, because actually Harrigan's paper talked about this. Long-run elasticity, you allow firms to relocate, is always going to be larger than short-run elasticity. So there are all these things in this. So you're going to ask, why do we care? Because trade elasticity, at the end of the day, is not just a theoretical concept. It is not a CES preference parameter. It is not a Frachet technology parameter. It has real-world complication. There are real-world implications. We want to know what is the impact of reciprocal tariff. When Trump tariffs set up, Indonesia, Sri Lanka, Malaysia call, tell me what is my trade impact. I cannot see, it's too small. What is the long run versus short run trade?
I estimate you have 1 minute.
Okay. What is the effects of non-tariff measures? Not talking about tariff, non-tariff measures. Can we somehow convert non-tariff measures into tariff using elasticity? How to evaluate the impact of trade agreement. So, but nevertheless, this paper is very good. I really appreciate the rigors that go into this. They tell us that different models will have different implied trade elasticity. It really depends on the context. And the more details the model is, in terms of margin, they will have smaller elasticity and therefore will have larger gains of trade. And they have very cool methodology to help us, guide us through how to use order statistics to estimate all this model. So first of all, it's my job, I have to say something. So this theoretical-based literature take model really literally. You fit everything according to the model specifications. Looking at price distribution could be affected by market power, exchange rate, substitution, transfer pricing, a lot of things. You restrict your estimation only for products, I think, with bilateral trade, importing and exporting. How about products that are not doing bilateral trade? Can we estimate elasticity at different level of aggregation? Can we have bilateral variation as well? So this is, just now you show us gravity regressions using regressing bilateral trade on distance. This is plain vanilla gravity regressions, regressing bilateral trade with distance of all the EU trading partners. When I have all the EU trading partners in the regression, the elasticity of estimate is this way, is a little bit more than 0.051. But if I exclude UK from the sample, just exclude one country, the elasticity estimate jump up to this much. Whereas when I exclude all other countries, the numbers are similar to this. So this graph is just a simple exercise to tell me that there is differences in terms of bilateral variation when you talk about trade elasticity. And that leads me to my teachers' work, Ralph Finstra and David Weinstein. They say that perhaps we can use transjob preferences rather than CES. And that will give us elasticity estimate that is inversely related to market share. UK have such a large market share in EU trade, so their elasticity will be different from the rest. And then, very nice gentlemen, honorable, I feel so grateful to know them, Jim and Peter's work, saying that perhaps we can evaluate welfare gains from trade, not using model, but using something called Trade Restrictiveness Index. And here, the Finstraw's work with his teacher, Dewards, tell us how to estimate product level trade elasticity, as well as how to evaluate bilateral gains from trade using TRI work. So I'm just going to say that good stuff, really appreciate this, have clearly illustrated that the more channels you have in your model, the more sophisticated the model is, the larger is the gains from trade. So perhaps push the frontier, think about whether you can bridge the differences between theory-based and empirical elasticity. So back to questions. While the real elasticity of substitution, please stand up. And here, Ina and Michael give us very good answer. The answer is it depends, right? It depends on the context of the paper.
All right.
Thank you so much.
Thank you very much.
Sorry that I take so much time.
Let's take maybe 4 or 5 minutes. But do you want to start with replying to the discussant? And then maybe we also have Oleg's question, which is the same as the
I just want to thank Hiau about this discussion. It was great. And then I'm going to say something embarrassing. I'm embarrassed that Ian and I wrote, I think, a really great paper, and then we sat on it for a long time for various reasons. And I think Ina did a great job presenting that, and we're really grateful for the organizers for including this paper on the program. I do want to say one thing that I personally struggle with, and it actually relates to Kiminori's paper too, is it's about like kind of an aggregation thing. Is like Ki was pointing out, you look at Broda Weinstein or her work, and you can estimate these elasticities all over the place. Yet, when you confront policymakers or people in charge of making decisions, they kind of just want things really simple and transparent. And you can kind of see that in the USTR report on when they set the reciprocal tariffs. They want one number. They don't want...
I don't know if I would use that as an example of academia.
I'm just like making the point that when you're confronted with like non-economists, they need transparency and simple answers, and they put a number in there. And I'm not saying it's perfect, but I'm saying that like that's the way policy's made.
No, I'm sorry. That's not the way policy is usually made in other countries. That is at a different level.
Let's let Mike to finish. And
Yeah,
then you
this
can
is
ask the question.
so. I think there's an issue about how we go from like really complicated world into kind of one number. That we can like kind of understand and think about that, and I think the Eaton and Korda model is like a great example of this. Actually, what Key think, because if you think in the Eaton and Korda model at the good level, things are perfect substitutes, but at the aggregate level, there's imperfect substitutability, and then you ask that question in Eaton and Korda, and you go, what's the right elasticity of substitution? Well, it kind of depends where you're looking, right? So this kind of then fits like when you think about like, for example, Broda Weinstein. If you do Broda Weinstein or Feenstra's method on Eaton and Korda, you don't get like the elasticity of substitution. You get some other parameter in the Eaton and Korda model. So I think this is a hard, and I mean, this is just kind of like going back to Oleg's question, it's a hard question. And the moment you deviate from just simple CS, where there's one number, things get really complicated really quickly. That's kind of your paper right there. And then I think like in heterogeneous agent trade, my work, I see that as well. It's a hard question, but okay, I'll stop. Let's go. Let's go. Yeah.
Maybe call. Yeah. Oleg should finish his original question, and then you can ask the question. Yeah. Why don't you finish your question?
No, I had a philosophical question, but let me ask it and just put it out there. So Ina, in the presentation, said, well, why this moment? And I think it's very compelling how you kind of approach it, given that we buy into the model, right? But I think the question is, why this model? Well, obviously, Item, Kortum, and all the other models you show are very important in our field. But then you're like, well, it's the interaction of the moment and the model. And you're like, when I look at prices of mango pens, and this is your job market paper, obviously, right, in Spain and Germany, am I learning about trade costs when I'm comparing prices of mango pens between Spain and Germany? Or you aggregate it to HS6 level or HS10, and it's a category of like cotton pens, and you see a difference between Spanish cotton pens and German cotton. Are we really learning about the trade costs from that data? And I think where Etam Kortum kind of went early on is like use price data to get a trade cost, which is internally consistent inside the model. But once you look at the world, like, are we really learning? And I mean, it goes back to how wide is the border paper by Engel and Rogers. But like, arguably, when we look at the price data, they tell us a lot more about markups, right, than they tell us about trade costs. And then, like, how do you deal with it? Do you reject the model altogether, or you keep the model but you decline the moment and so on? But this is like, it's a huge philosophical question.
No, I mean, but I think I would I mean, I'm totally sympathetic to this thing, but the defense is that's why kind of like this, when we project it on things like distance and border, that it is, and I don't think this is, I don't know if this is clear to everyone, like the goal is to proxy for the trade cost. That's unobservable fundamentally. The price gap isn't a way to do that. And then Oleg's point is exactly right. There's tons of stuff in the price gap that have nothing to do with the trade costs. But when we project the price gap on like distance and border, they're correlating with it. And that tells us there is content in there. Now, how do we sort out what is other stuff versus the elasticity? Well, that's the role that the model plays. And you do have to take a stand on the data generating process. That's the cost of our approach.
We don't have so much time, but maybe you can ask the question and then...
Yeah, it's just a very quick and simple question. So maybe 1 million elasticity is too much for me, but maybe we can have more than one. Can't you just use your method like to estimate elasticity for, I don't know, like 10 sectors, 20 sectors, so that it is useful? Like,
no, so Ina, there was a paper by Kimu Yi and co-authors that followed up on our approach and did it for multiple sectors. And then they got kind of pretty reasonable. When you kind of looked at how the elasticities ranked across sectors, like stuff that you'd think would be more substitutable, less substitutable, you got that kind of ranking. So it is, the only question is it's a data limitation. Like we really rely on the model, and then we rely hard on like prices that are collected with the explicit purpose of being comparable. That's why, like, if you go to like HS6 unit values or HS10 unit values, you don't know if you're comparing apples to Honeycrisp to like Kizu, whatever. I don't know. Like this, my kids only eat Honeycrisp, but the thing is, like, you don't know. But the ICP is explicitly designed to make sure it is exactly the same product that is being collected. So.